tutorial discusses ionic, covalent, and metallic bonding in more detail. Ionic bonding occurs between a metal and a nonmetal element. It's a transfer of electrons from one element to another to form a cation and an anion. A cation is a positively charged particle, while an anion is a negatively charged particle, meaning that the cation lost electrons while the anion gained electrons. The strength of this bond can be calculated by Coulomb's law, which is that energy is equal to a constant times the charge of one times the charge of the other divided by the distance between them. The ionic bonding results in an attraction between the two charges, the positive from the cation and the negative from the anion. So let's talk about the general properties of these bonds. The physical properties are that they have a very high melting point, usually greater than 300 degrees Celsius, and very high boiling point as well. Keep in mind this is the pure compound, not as a solution. They also tend to be hard and brittle. When you think about ionic compounds, think about table salt, because that's a great example of an ionic compound. You have a positive from the sodium, you have a negative from the chlorine, and it's something that you're most likely familiar with. So you can visualize table salt as being hard and brittle. You can visualize table salt as something that doesn't melt very well. They form crystalline solids at room temperature. They do not conduct electricity, but when they're in the liquid state, conduct electricity in the solid state, but when they're liquids, they act as a very strong electrolyte, meaning that they can conduct electricity. Solid and liquid states are thermal insulators. Many solid ionic compounds are soluble in water. However, not all of them are, so you need to check your solubility rules. So let's switch gears to our covalent bonding. This is a bond that arises from the mutual attraction of two nuclei for the same electrons. So when we look in here, here's one nucleus, here's the other nucleus. They're sharing the electrons between them, and they both want them. So the electron sharing is what's resulting. That's what's happening. The bond is a balance between the attractive forces, which is the protons attracted to the electrons. However, it's also the repulsive forces of the electrons repelling each other and the protons of the nuclei repelling each other. The bond is a result from the overlap of atomic orbitals on neighboring atoms. This more specifically will be discussed in future tutorials. It occurs between nonmetal elements. So what are the properties of these? These compounds of nonmetals are made of individual molecular units. When we were looking before at the salt, we had Na and Cl. If we looked at an entire grain of salt, this would just be repeating, with the positives and negatives being as close to each other as possible. And this becomes a clump. Whereas with molecules, they form individual molecules, individual units that are attracted to one another in smaller doses. So they're not as attractive to each other as the ionic. They have lower melting points as a result and lower boiling points, generally less than 300 degrees Celsius. The hardness and brittleness vary depending on the strength of the intermolecular attractive forces. Note the word intermolecular. That's between the molecules. Which are the dipole-dipole and the dispersion, which we're going to be discussing in a minute. Many of them are soft and waxy. They can be found in all three phases, all three different states of matter at room temperature: solid, liquid, and gas. So what is metallic bonding? It's the simplest theory of metallic bonding involves the metal atoms, releasing their valence electrons to be shared by all the core atoms in the structure. So if we look here, this is an example of sodium. The purple dots, the purple circles, are representing the nuclei and the core electrons, while the blue, lightly shaded area is supposed to be the valence electrons. And what's happening is these core and nuclei are sharing and blending together all the valence electrons. And this is what's creating kind of like a sea of electrons. It is the organization of metal cation islands in the sea of electrons. Electrons delocalize throughout the metal structure. Bonding results from the attraction of the atom core from the delocalized electrons. So what is metallic bonding? Is the electron shared differs from typical covalent bonding. It is the electron sharing among the atoms in the compound, which is the same as covalent, and communal sharing of electrons, which is different than covalent. And it's forming that sea of electrons. There's still this balance here like there is in covalent bonding, where the positive and negative, the protons and the electrons, are attracting each other, yet there's still the electrons and the protons. The electrons are repelling the electrons and the protons are repelling the protons. So there's a balance between those two. The Lewis theory explains the properties of metals and their compounds, which are called alloys. The attraction of the metal atom core for the delocalized electrons is strong because it involves the full charges, not just partial charges. The low ionization energy of the metals allows them to lose electrons easily. They have high melting points. To melt, and this is because some of the attractions of holding the metallic crystals together must be broken in order for it to melt. Melting points of metals generally increase from left to right across the period and decrease down a column. So it increases up and to the right. All have very high boiling points, and that's once again because the attraction must be broken in order for it to boil. All of these are solid at room temperature with the one exception of mercury. And as solids, they're malleable and ductile. Malleable means that they're able to be bent and shaped, while ductile means they're able to be pulled into a wire. And then the surface reflects light. Solid and liquid states conduct heat and electricity. Electrons are delocalized and they are able to move through the metallic crystal. Electrical conductivity takes place when charged particles, like electrons, are able to move through the structure. The ability of metals to conduct electricity decreases with increasing temperature. This gives you a general idea of the properties of the different types of bonds. We're going to be exploring them even more closely as time goes on.